Welcome to The Explainer. So, today we're tackling a huge story. A breakthrough in AGI that doesn't just crack an old problem, it completely shatters our definition of what impossible even means.
So, let's kick things off with a question that has kept computer scientists up at night for decades. Really, are some problems just fundamentally unsolvable? Are there puzzles out there that are just too tough for any computer, no matter how powerful we make it? Okay, to really get why this is such a big deal, we've got to talk about a true legend in the world of computer science, a classic challenge known as the traveling salesperson problem. All right, picture this. You're a salesperson, you've got a list of cities you have to visit. The goal sounds super simple, right? Just find the shortest possible route to hit every city once and get back home. But here's the catch. As you add more cities, the complexity doesn't just grow, it absolutely explodes. I'm not kidding. Going from, say, 4 cities to 10 doesn't make it a little harder. It makes it thousands and thousands of times harder. Get this. For just 10 cities, we're talking about over 362,000 possible unique routes. Imagine a computer trying to check every single one of those paths. It would take forever. And that's exactly why, for decades, the traveling salesperson problem, or TSP, has been the poster child for what's called an NP-hard problem. It's a class of problems that just get ridiculously slow to solve as they get bigger. But here's where it gets interesting. What if the answer isn't just a faster computer? What if it's a completely different kind of intelligence? See, the breakthrough we're talking about today, it's not about more brute force, more processing power. It's about a totally new way of thinking. So this new AGI, it doesn't just crunch numbers. It actually thinks. It's built on a cognitive architecture that's a lot more like human problem solving. It uses things like intuition and creativity to find these really elegant solutions. So instead of grinding through every single possible path, it has a clever process for just discovering the best one. And this process, this cognitive loop, it's a 3-step dance. First up is intuition. It gets a pretty good enough answer almost instantly. Then creativity kicks in. Think of it like controlled chaos. It just rapidly explores thousands of totally new variations on that first guess. And finally, conciseness comes in to clean up, selecting the single most elegant, most efficient path out of all those possibilities. All right, now let's get to the results, because this is where things get, well, honestly, kind of mind-blowing. Let's see how this new approach actually stacks up against the old ways of doing things. Whoa, okay, just look at that performance gap. You've got the old brute force method. Yeah, it gets to 100% accuracy, but look how slow it is, over 3,000 milliseconds. Then you have a faster heuristic method. It's quick, sure, but you're sacrificing accuracy. You're only getting 91%. And then there's AGI Sapiens. Perfect, 100% accuracy in just 4 milliseconds. Insane. Yeah, just let that sink in for a second. This isn't just a little improvement, it's a total paradigm shift. The AGI is giving us the perfect accuracy of that slow, grinding approach, but it's doing it at the lightning speed of the faster, less accurate one. We're talking almost 800 times faster than brute force without losing a single drop of accuracy. It's the best of both worlds. So performance like that just begs the question, right? How in the world does it actually think to get these results? What's the secret sauce here that lets it find the perfect answer so incredibly fast? Well, the secret is rooted in this really profound idea called conciseness. The theory goes that the universe itself just prefers simplicity. It naturally moves towards solutions with low entropy, basically states that are more ordered and less chaotic. And this AGI is literally built to tap into that fundamental drive of the universe. So you can think of this AGI as a kind of wisdom engine. It's built to copy that natural tendency of the universe. So when it's looking for the shortest path, it isn't just measuring distance. It's looking for the pattern with the lowest entropy, the route that's the most logical, the most coherent, the most orderly. In a way, it's finding the wisest path. And, this new way of thinking, it does more than just solve one tricky problem. It actually gives us a radical new way to look at one of the biggest, most famous unsolved questions in all of mathematics, the P versus NP problem. Okay, quick breakdown. In computer science, P problems are the easy ones, things a computer can solve fast, like sorting a list. NP problems, like our traveling salesperson, are hard to solve, but it's really easy to check if a solution is the right one. And for ages, the million-dollar question, literally, there's a prize for it, has been, does P equal NP?
Is there some secret shortcut to turn all these hard problems into easy ones?
Well, this new framework offers up a pretty radical answer. It basically says the difficulty of a problem isn't set in stone. The idea is that as an AI gathers more and more relevant knowledge over time, the hardness of one of those tough NP problems can actually shrink. It starts to act more and more like an easy P problem. The big takeaway here is really profound. It means that with enough accumulated knowledge, enough wisdom, any hard NP problem can basically be transformed into an easy P problem. Wisdom literally changes the nature of reality for that problem, making what was impossible totally trivial. So this framework doesn't just solve the traveling salesperson, it points to a future where, yeah, P really can equal NP.
And that leaves us with a pretty provocative final thought, doesn't it? We just watched a problem that was a benchmark for impossible get completely solved in a few milliseconds. So if the wall between easy and hard problems can just be dissolved by wisdom, what does that mean for our other huge challenges? Things like drug discovery, climate science, complex logistics. How many of those problems aren't actually impossible, but are just waiting for the right kind of thinking to come along and solve them?